Here is a quick question that seems simple but actually explains everything you need to know about how modern AI works. How does ChatGPT knows that car and automobile means basically the same thing? They are completely different words. They look different, they sound different, they come from different parts of human language, but a moment an AI reads them and understands they are the same concept are interesting. Your brain does this instantly through the connections and memories accumulated over the lifetime. And AI doesn't have memories, it has numbers. Today we are talking about embeddings, and once you understand this one concept, you will see why this is literally the foundation of how modern AI actually understands what you are asking it, not just the words you typed, but what you actually meant. This changes everything about how you think about AI. There is a misconception everyone has about how AI works. People think it reads words like it's a dictionary. Word in, definition out. But this breaks down the moment you move beyond simple lookups. If someone writes, "My sedan had a flat tire," and you are searching for the broken wheel, a keyword system won't find it because the exact word don't match. Same concept completely missed. Or if someone writes, "The CEO bought the new Tesla," a dictionary-based system would be lost. There is no car keyword anywhere, yet it is obviously about a vehicle. This is the core problem with keyword-based search. Words are just labels. The actual meaning is deeper than that. Without understanding meaning and semantic level, AI can't do semantic search, can't make accurate recommendations, and cannot really understand what you are asking. It is just pattern matching on the surface of the language. The solution is embeddings. Here is the non-technical version. An embedding is a list of numbers, usually 100 or 1,000 of them, that represents the actual meaning of a word or piece of text. When AI reads car, it converts it to something like, say, 184 numbers. Then it reads automobile, it converts that to a different set of 384 numbers, for example. But there is the key part here. Those two lists are very similar to each other. Think of it like a map. Paris and France are related concepts. France is a country, Paris is the city. If you plotted them on 2D map, they wouldn't be the same spot, but they would be near each other. Embeddings works exactly the same way, except instead of 2D map, you have got a space with the hundreds of dimensions. Words with similar meaning end up with the similar coordinates in the high-dimensional space. Car and automobile are near each other, car and banana are far apart. This is what we mean by meaning having geometry. Let's walk through this with a concrete example. Imagine you're building a recommendation system and user searches for electric vehicles. There is the exact process happening behind the scene. Your search query gets converted into an embedding. 384 numbers that represent the concept of electric vehicles. But before your search ever happened, every document in the database was already pre-embedded. A document about electric cars is a vector. Another document about battery-powered automobiles is a different vector. A document about cookies is yet another vector sitting in a completely different region of the mathematical space. When you search, the system calculates the distance between your query vector and every document vector. It is geometric distance. How close are these numbers to each other in what high-dimensional space? Documents closer to your query rank highest. The document about battery-powered automobiles doesn't contain the word electric or vehicles, but it's geometrically very close to your query. It ranks high. You see relevant results. Electric cars, EVs, or batteries-powered automobiles, all because the meaning concepts are very close and they are not words. The entire process takes milliseconds. The key insight here is that you're searching by meaning, not by keyword as I mentioned before. The document can use completely different language and still found because the geometry of the meaning concepts them. A major e-commerce platform tested embedding-based search versus keyword search and found 38% of improvement and relevance. Someone searching men's winter coat found exactly what they wanted even then listings said thermal menswear or heavy jacket, which are different words but have the same meaning. Recommendation engines like Netflix, Spotify, and Amazon all use embeddings. When you watch the sci-fi show about the space exploration, the system doesn't just find other space shows. It understands the deeper themes, adventure, wonder, discovery, and recommends shows with the similar meaning, even across different genres. The geometry of your watching history points towards shows you actually enjoy. There is also the retrieval steps in RAG systems, retrieval augmented generation. When ChatGPT needs to find relevant documents before writing an answer, it searches embedding space. It finds the most relevant information by meaning, which is why it can answer questions about concepts it wasn't directly trained on. One customer support team switched from keyword search to embedding-based search and cut ticket resolution time by 18% because their reps were actually finding relevant previous solutions instead of keyword-matched dead ends. You now understand the geometry of meaning. You understand why embedding are the foundation of modern AI, why semantic search works, why RAG system can find relevant documents in millions, and why recommendation engines are accurate, why duplicate detection actually works, and why self-driven cars can recognize stop signs in different language and orientations. And now you cannot unsee this. The next time you use the ChatGPT and it finds a relevant document buried in thousands of others, you will know that's embedding working. The next time the recommendation surprises you by being exactly right, that's embedding geometry doing this job. Most importantly, you can now evaluate when embeddings are the right tool. If the keyword search failing, then use embeddings. Need meaning-based similarity? Embeddings. Large-scale semantic? Again, embeddings. If you found this video helpful, learned something new, or discovered ways to simplify your workflow, boost your productivity, or even save money, please subscribe my channel and hit the like, because it really helps me to grow and keep digging to discover new things and continue creating more content like this. Also, leave a comment below with your thoughts, questions and experiences. My goal is for us to learn, grow and build real AI expertise together, and your feedback is an important part of that. Thanks for watching and see you in the next videos. Laughing, dance all night.